This is the multi-ratio gearbox from Radionics. These are the spec sheets, as you can see. And here's the video of the experiment. This is our experimental setup. We've got our gear. We've got our hoist assembly here. We've got our mass of 100 grams passed in a bottle. And we start the motor going. And we can measure our current draw as well. So that's pretty much it. A few calculations to do now. Okay, here we have a few of the calculations that we did associated with the test. We can see that the input voltage is 12 volts. Our no load speed is 88 RPM. Now, if you look at the data sheet at the start, we can see that the for a no load speed of 12 volts and we have a setup of 64:1, so that's my reduction table. We should have a no load speed of 131 RPM and we've around 88, so that's not quite correct. Now we do have some load on it because of the shaft and the arrangement by which we lift the load, so that's okay. Okay, when we actually lift the load, we get a current, we measure a current of 0.080 amps. So your electrical power input is volts by amps, so we've 0.96 watts. Again, if you look at your data sheet, we note that the power rating for the motor is 1.62 watts. Now, usually your power rating, it'll draw more current the higher the speed, so we're not quite at that yet. What else then? So we lift a mass of 100 grams, is lifted through a distance of 615 millimeters, and we time it and it takes 6.86 seconds. Therefore, we get a mechanical power output. It is work done divided by time, so MGH divided by time. So we get a mechanical power output of 0.0879 watts. So our efficiency from electrical to mechanical is approximately 9.15%, which is kind of thereabouts for these type of motors, I understand. If we check the amount of torque we applied there, if the diameter of the groove in the hoist is 20 millimeters, thus the radius is 10 millimeters, which is 1 cm, that's giving me a torque in gram cms of 100 gram cms, which is approximately equal to 0.01 Newton meters. Again, if you look at the spec sheet, it tells me that the torque, maximum output torque is 25 gram cms. Now again, I'm not entirely sure what that refers to. It might be at the lowest, at the highest speed from the motor, and therefore that'll be the lowest torque. But we're certainly getting greater than that, which is what we want. We want to get a high torque at a low speed to move objects that we want to move with the system. Okay, that's it. Thank you.